Welcome back. We are continuing with the part 2 video of lesson 15.1. In this we are going to learn the third technique, which is factoring by grouping. Alright. So factoring by grouping, when do I use this method? When do I use this technique? So I'm going to be using this when I factor polynomials that has more than 3 terms. Alright. I'm going to be using this for polynomials that has more than 3 terms and degree of the polynomial being 3 or more. Okay, so it should have more than 3 terms, and or it could be a polynomial of degree of 3 or more or even less. So it doesn't matter, but whenever it is 3 terms or more, I'm going to be using this method, alright, or using this technique. So let's take a look at our example 1. So here I have my polynomial. This polynomial has 4 terms. Okay, so I'm going to be using a method that is factoring by grouping. Alright, so the key here is for you to first put your polynomial in standard form. Okay, so standard form, putting it in standard form, for those who haven't learned this, putting it in standard form is arranging all the terms from the highest degree to the lowest degree. Okay, so start with the highest degree term and put it in order to the lowest degree term. So this degree 3, degree 2, degree 1 and degree 0. So you have all those terms. You are arranging it from highest to the lowest. That's putting it in standard form. Alright. So after having done that, the first step to any factoring problem is I'm going to be using the technique 1, which is I want to look for a GCF. I want to look for a GCF. If you have one, pull it out. Pull out a GCF. Okay, so I want to first look for a GCF between all these 4 terms. If I have a GCF, I want to pull that out first. Okay, so let's take a look at all our 4 terms. Do I have a GCF? So my numbers are 12, 9, 20 and 15. There is no greatest common factor between all these 4 numbers. Now let's look at the variable part. I have an a cube, a square, a, and there is no variable there. So I can't pull out any variable as a greatest common factor because there is no variable there. So in effect, there is no greatest common factor in this polynomial. So I don't have to worry about it. So I just checked it. If it was there, I would have pulled it out. But it's not there, so I don't have to worry about it. Now when I look at it, the next step is for me to group. Remember, I need to have even number of terms for me to be able to group it. Okay, so if you look at it, I'm grouping the first 2 terms and I'm grouping the last 2 terms. In the first 2 terms, after I grouped it, I'm looking at the 2 terms. Do I have a greatest common factor between the 2 terms? Of course I do. Between 12 and 9, the greatest common factor is a 3. Between a cubed and a square, there are 2 a's that are common. A cube is a times a times a. A cube is a times a times a. A square is a times 1. So there are 2 a's that are common. So a times a is a square. So between a cube and a square, my a square is the greatest common factor. So always the lowest power going to come out as the greatest common factor. So what is left? Yeah, what is left of these 2 once I pull out a common factor of 3a squared? So when I pull out a factor of 3 from 12, see, I'm pulling out a factor of 3, right? So 12 is 4 times 3. I already pulled out the 3. What's left is a 4. Out of the a cube, I already pulled out an a square, and what's left is an a. So of the first term, I have a 4a that's left out. So 3a squared times 4a is going to give me that 12a cubed. I'm reversing the process, right? So now what's left of my second term? I pulled out a factor of 3 from 9. So what's left is a 3. The minus sign is a minus 3. Out of the a square, I pulled out an a square. So there is nothing left of a square. So there is only 1 that is left. So 3 times 1 is a 3. So I pulled out this. I'm going to just multiply a quick check and see if I get back these 2 terms. So 3a squared times 4a is going to give me 12a cubed. 3a square times 3 is going to give me a negative 9a square. So I got my terms back. So what I did here, pulling out the GCF, is correct. Now I look back at my last two terms that I grouped. When I look at these two terms, I'm going to be pulling out a GCF between these two terms also. But before I pull out my GCF, I need to make sure whatever is left out of these two terms after I pull out the GCF should be a 4a minus 3. Because in the next step, we are going to be using the technique of pulling out a common binomial factor, okay? My common binomial factor is that 4a minus 3. So when I look at it, I have a 4a I want to have a 4a minus 3 there because I have a 4a minus 3 here. So what should be my greatest common factor that I pull out of these two terms? Between 20 and 15, the greatest common factor is a 5. Is it going to be a plus 5 or a minus 5? So this sign that I'm going to put here is very essential, all right? So when I look at it, 5 times 4a is going to give me a 20a, and 5 times negative 3 is going to give me a negative 15. So this has to be a positive 5 so that I get back the terms that I originally had. So positive 5 times 4a will give me a positive 20a, and positive 5 times negative 3 is going to give me a negative 15. So I have this step, all right? So from here, I grouped these two terms, the first two terms and the last two terms, and I pulled out a greatest common factor between these two terms and these two terms, and I ended up with a common binomial factor between these two. So the common binomial factor is a 4a minus 3. So I'm pulling out group, first two terms and the last two terms. Then pull out a GCF for each group. Okay. Make sure you have a common binomial factor. So now the next step is you're going to pull out a common binomial factor. This is technique 2. So it comes handy here, yeah, binomial factor. So when I pull out a common binomial factor, which is 4a minus 3 here, what is left out of my first term is a 3a square. What's left out here is a plus 5. So I pull these guys out. What's left is my other binomial factor. So I got two binomial factors now. So I started with 4 terms and I split it up and I got 2 factors. So I'm saying that these two are the guys that multiply to give me this polynomial. So let's check. So this is a very essential part that you need to do until you get familiar with these procedures. All right. So all these things are just procedural. So I want to check if I got it right. How do I check it? Multiply them back to see if you end up with that polynomial. All right. So I want to multiply it back. This is binomial times binomial. You can use the table method, or you can use the distributive property, or you can use a FOIL. All right. So now I want to multiply it back. 4a times 3a square is a 12a cubed. 4a times 15. Sorry, 4a times 5. My bad. 4a times 5 is a 20a. Now negative 3 times 3a square is a negative 9a square. And negative 3 times 5 is a negative 15. Now if I rearrange the terms to put it in standard form, I will write the a cubed term first, then comes my a square term, then comes my a term, and then comes my constant term. So when I look at it, I got back my original problem, 12a cubed minus 9a square plus 20a minus 15. So my factoring is correct. Okay, so this is factoring by grouping. I'm going to do one more problem where you have to factor out a GCF. Okay, the one more problem where we have to factor out a GCF. 4g power 5 plus 20g power 4 plus 2g square plus 10g I'm seeing that this polynomial has more than 3 terms and the degree is more than 3 also. So I'm going to be using the method, the grouping method or grouping technique to factor my polynomial. Okay, so when I start factoring any polynomial, the first step is always to look for a GCF and pull it out. Okay, look for a GCF, pull it out. So I'm going to be pulling out a GCF between these 4 terms. If I have one, so I'm looking at it, it looks like it's got one. Okay, so I'm looking at my numbers 4, 20, 2 and 10. So between the numbers, my greatest common factor is 2. If you want to stop the video and figure it out by yourself, please do so. Okay, so my greatest common factor between the numbers is a 2. My greatest common factor between the variables g power 5, g power 4, g square and g, always the lowest power is going to come out as a greatest common factor. So my g is a greatest common factor. So I have to write out what's the other factor that's left out of these 4 terms. So I have 2g. I pulled out a 2 out of 4, so a factor of 2 is still left. I pulled out a g out of g power 5, so I still have a factor of g power 4 that is left. So if I multiply it back, I'm getting back that 4g power 5. And in the second term, I pulled out a factor of 2, so I have a 10 left. I pulled out a factor of g, so I have a g cubed that's left. In my third term, I pulled out a factor of 2, so I have just a 1 that is left. 2 times 1 is 2. And I pulled out a g out of g square, so I have a g that's left. Plus, out of a 10, I pulled out a 2, so 2 times 5 is 10, so that's a 5 that's left. G, I pulled it out. There's nothing left out of the g. All right. So I have my greatest common factor, and I have the other factor, which is still a 4-term polynomial, right? So I still want to go ahead and factor this further. Okay, so there is a term called factoring completely. I'm going to keep on splitting it up, factoring completely. Okay, I want to split up the polynomial, right? Factoring is splitting up the polynomial. Factoring completely means I want to continue to split it up as much as possible until I can't split it anymore, until they are all prime factors, right? You have prime factorization. This is prime factorization. I'm splitting it until I can't split anymore, all right? So here I have a GCF and I have the other polynomial. So GCF, I'm going to keep it aside for a minute until I go ahead and factor that out. Okay, so this guy is waiting there. I'm going to bring it back in my final answer. All right, so I want to focus on 2g power 4 plus 10g cubed plus 1g plus 5. Now they have 4 terms. Now factoring by grouping. Factor by grouping. So I'm grouping the first 2 terms, grouping the last 2 terms. Now again I want to look for a GCF between these 2 terms. So 2 and 10, the greatest common factor is 2. Between g power 4 and g cubed, the g cubed is going to come out. What's left? 2 has come out, so there is only a 1 that is left. G power 4, g cubed has come out, so there is a g that's left. I have a 10g cubed, a factor of 2 has come out, so I have a 5 that is left. G cubed has come out, so there is nothing left there. So it's 2g cubed times 1g plus 5. If I quickly multiply it back, 2g cubed times 1g is going to give me 2g power 4. 2g cubed times 5 is going to give me 10g cubed. So I'm getting back my 2 terms. So remember, I want to keep the binomial factor to be the same on this side also. Before I pull out a GCF between these 2 guys, I want to make sure my binomial factor is one and the same. So I have that. So I have my binomial factor that is common. When I have that 1g plus 5, I pulled out a greatest common factor between these 2 terms, which is a 1. So that's a plus 1. So if I multiply it back, I'm going to get back my terms. So I have my greatest common binomial factor now, 1g plus 5, 1g plus 5. I pulled it out. What's left is a 2g cubed plus 1. All right. Now remember, I pulled out a GCF earlier, which is waiting there. I'm going to put it along with my other factors. So my complete factorization